So in this part we will understand how to integrate trigonometric function of type 1. Type 1 is random thing, but the idea is you will have a question where on the denominator you will have same trigonometric ratio. We will have sine or we will have cos and we will have some angle associated with this. Look at this. They have used cos and here they have used sine. Correct? So if we have two things on the denominator, if both are same, then how we will respond? If both are different, then how we will respond? Okay? So the point is if you have same trigonometric ratio, then multiply and divide by sine. Okay, multiply and divide by sine. Sine of what? We will handle. Sine of this angle minus this angle. Okay, b minus a, and then you have to manipulate. Here also you will observe that it is same trigonometric ratio has been used. So it is multiply and divide by sine, same sine, and then final angle minus initial angle. So if it is different, you will be using what? Cos. What is that? Multiply and divide by cos b minus a. Okay, so you will have these two situations in type 1. Okay, now look at this, how we will manipulate things. So suppose that we want to handle the first situation. So in first situation, you know that you will be multiplying and dividing by, as both are same, so we will be using sine. And if you'll observe, this is a constant. Why it is constant? Because the variable is x and here we don't have any x. Correct? So this thing will become constant. So can I take that thing outside? So sine b minus a taken outside. Now look at this, how I will manipulate this thing smartly. So it is sine x minus a, and then you have to write minus. Okay, you will be using x minus b, and look at the beauty. If you will open this bracket, this is nothing but b minus a. Correct now? So that's why we have did this one. Now I hope it makes sense to you guys. Okay, and later you will understand that why we have taken this idea, why not some other idea. Okay, so look at this. So cos x minus a cos x minus b, and then we have dx. Now you have sine a minus b, so you can apply that formula, sine a minus b wala. Sine b minus a integration of sine a cos b minus cos a sin b. Okay, and upon this cos x minus a cos x minus b dx. Now if you will observe the first entity, look at this. If you'll observe these two things, you may feel that, sir, cos x minus b will be neutralized by cos x minus b. Okay, and if you will observe this thing, you will say that, sir, cos x minus a is being neutralized. Okay, so let's simplify things. So we have sine b minus a integration of cos and cos gone, so we are left with tan x minus a, and then we have minus cos gone, tan x minus b dx. correct? Now you know that the integration of 10x is log sec x, है ना? So 1 by sine b minus a, and then we have log sec x minus a minus log sec x minus b, and then we have integration constant c. You know that here we have log m minus n, so you can apply log m by n concept as well. Same thing you will do over here. Okay, so here what will happen, you will have cot a minus cot b. Here we got tan a minus tan b, no? So there you will get cot a minus cot b, and you know that the integration of cot x is what? Okay, now suppose that you are in this situation. So you know that if it is different, we will be multiplying and dividing by cos. So look at this, what will happen. So it will become cos b minus a, and look at this, how we will manipulate this one. So it is cos x minus a minus x minus b dx. Okay, we have sin x minus a cos x minus b. Okay, so the point is, we will open the bracket cos b minus a, and we will have cos x minus a cos x minus b, and then plus sin x minus a sin x minus b dx. Okay, and we have sin x minus a and cos x minus b. Now look at this. If you will observe the first entity, you will end up neutralizing cos x minus b, and you will be having cot x minus a. And if you will observe the second component, you will end up neutralizing sin x minus a. You will be left with sin x minus b by cos x minus b. So it will become tan x minus b. I hope from here you can neutralize things, and from now onwards, if you will observe these kind of questions where in the denominator we have sin, cos, or sin cos, we can handle those situations gracefully. Okay.